For practice number 1, we have a dart being thrown up in the air. 58 feet per second is initial velocity, angle of elevation 41. So let's just start off by writing the equations. So I'm going to have 58 cosine 41 t and y equal negative 16 t squared plus 58 sine 41 t. They didn't say anything about an initial height, so we'll just assume that it is 0 for the time being. Next question of this one asks us what is the maximum height and at what time did it reach that. So I'm going to focus on the y equations, and we know that we can find the maximum by doing t equals negative b over 2a. So it's going to be negative 58 sine 41 all over 2 times negative 16, and I type that in the calculator. You get 1.189 seconds. Units are important, and I'm going to make sure that I store this. Next, to actually find the maximum height, I'm just going to plug this in to the y equation, and I will get 22.63 feet. So those are my 2 answers. When will it hit the ground? So it hits the ground when y equals 0. So I'm just going to note what a, b, and c equal, and then write out the quadratic formula. I hope you're singing along. No? Okay. I'm going to use the program in the calculator. That's going to give me 0 and 2.378. So it will hit the ground at 2.378 seconds. Next question of this one asks how far in the horizontal direction will this thing travel? So I'm just going to do x at that value, just using the stored value in the calculator and plugging in what the x equation is, and I get 104.1 feet. And there you have it. That is practice 1. For practice number 2, we have a golf ball being hit, initial velocity of 133 feet per second with an angle of 36. So I can write my 2 equations. X equals 133 cosine 36 t. Y is going to be negative 16 t squared plus 133 sine 36 t. They didn't tell me anything about the y starting height, so I'm just going to assume it is 0. So it asks when and where the ball will hit the ground. So it hits the ground when y equals 0. So I'm going to use the quadratic formula. So I just have to write down what a, b, and c are, and then plug it into the program in the calculator. Remember that this is the level of work that I'm looking for. And we will get 0 and 4.886. And I'm just going to plug that in for the x equation to see where that actually is. So using the stored value in the calculator, there we go. So at 4.886 seconds, it will have traveled 525 feet. The second part of this is it going to clear a tree that is 275 feet away from Justin and is 9 feet high? So this is essentially a collision style question, so I'm going to set the x values equal to each other. So 275 equals 133 cosine 36 t. I will solve for t by just dividing all of that other stuff away. 133 cosine 36. Plugging that in that fancy calculator, getting 2.55. I'm going to make sure to store that, and then I'm going to plug it into the y value to compare what the y value is at this height, which is 95.287. So 95 feet is definitely bigger than 9 feet, so our answer for this one is yes, it does clear that tree. For practice 3, which is somehow labeled practice 4 on my answer key, we have kind of a tricky one, actually. So Independence Day fireworks, Memorial Park, fired at an angle of 82 degrees with the horizon. The technician firing the shells expects them to explode 300 feet in the air 4.8 seconds after they are fired. So let's fill in as much as we can to the equations to see kind of what's missing here. So I have x. They didn't tell us an initial velocity, so I don't know that. We do have an initial angle of 82. Y, I think we can fill in pretty much everything again except for that initial velocity. And yeah, that's our start. And we got some other information that they gave us, right? Which is that we want when y equals 300, we need that to happen at t equals 4.8. So we can use that information to backtrack and figure out what the velocity needs to be in order for this equation to work out. So I know that y has to equal 300 when t equals 48. So I can just plug this carefully into the calculator, and it will allow us to figure out what the initial velocity is, okay? So I'm just going to add this term to the other side and divide by the 4.8 times sine 82. So that's going to give me v equals 668.64 divided by 4.8 sine 82, which is approximately 140.67, which I am going to store because we're going to need it in the next part. And this is a velocity, so it is in feet per second. So that is the answer to this first part. Now, second part is just kind of worded a little tricky for us. But basically, if this is the spot where the fireworks are being launched at, right? So they're being launched, and then it's going to go up here, and then it's going to blow up and be pretty, and everyone's going to be like, ooh and ah. And this question is saying that from where this explosion happens, we need to make sure that 100 yards in either direction, that we have safety barriers put up. Okay, so we just need to figure out where those safety barriers need to be. So now that we have this initial velocity and we know that it's going to explode at 4.8, we can actually plug in a lot into this x equation. So we can figure out where is this x part by just using this initial velocity, 140.67, cosine 82 at time 4.8. And when we do that, we're going to get 93.97, but remember that this is in feet, so I'll divide by 3 to get 31.32 yards. So that's what this value is right here. This is 32.32 yards. So I'm just going to subtract 100 from that. Okay, and that will give me this value right here, which is going to be negative 68.67 yards. And it will give me this value right here, which is 131.32 yards. So from wherever 0, 0 is, which is where this thing is being launched from, we need safety barriers in the horizontal direction that we're measuring here, negative 68 feet behind it, and 131 yards, not feet, in front of it. And there you go. That is the practice for day 1, Intro to Projectile Motion.